The second question that we have requires a bit of manipulation. We have been given three lines whose direction cosines are L1, M1, N1, L2, M2, N2 and L3, M3, N3. These three lines are mutually perpendicular lines. We need to find out the direction cosines of a line whose direction ratios are given as L1 plus L2 plus L3, M1 plus M2 plus M3 and N1 plus N2 plus N3. We also need to show that this line is equally inclined to these three lines. So for solving this question, let us first write down all the information that we have been given in this question. So the first information is that these three lines are mutually perpendicular. Therefore, since these lines are mutually perpendicular, we can write, let us write for these two first, L1 L2 plus M1 M2 plus N1 N2 is equal to 0. Since these two are mutually perpendicular, this will be equal to 0. This can be thought like this. The direction cosines actually represents the direction of the line, that is L1 I cap plus M1 J cap plus N1 K cap. This is the direction in which the line is. For the second line, L2 I cap plus M2 J cap plus N2 K cap. This is the direction in which the second line is. Now since the angle between the direction of these two lines is 90 degree, therefore the dot product should be 0. That is L1 L2 plus M1 M2 plus N1 N2 is equal to 0. Therefore this is how we get this equation. You should learn to write this directly also. Therefore similarly we can write L2 L3 plus M2 M3 plus N2 N3 is equal to 0. And again we can write L3 L1 plus M3 M1 plus N3 N1 is equal to 0. Now these three are the equations we have. We have another equation which people generally forget, that since these three are the direction cosines, therefore we can write L1 square plus M1 square plus N1 square is equal to 1. Also similarly for these two we can write L2 square plus M2 square plus N2 square is equal to 1, and for the third one L3 square plus M3 square plus N3 square is equal to 1. Now these six equations are there with us. The direction ratios of this line is given. We need to find out the direction cosines. So for finding out the direction cosines of this fourth line, we know that for a line with direction ratios P, Q, R, the direction cosines are P upon root over P square plus Q square plus R square, comma Q upon the same quantity and R upon the same quantity root over P square plus Q square plus R square. Therefore, let us find out the value of root over L1 plus L2 plus L3 whole square plus M1 plus M2 plus M3 whole square plus N1 plus N2 plus M3 whole square, and we can easily find out the value of this quantity with the help of this given information. Let us see how. This can be written to be equal to root over summation L1 square. This summation L1 square means L1 square plus M1 square plus N1 square plus summation L2 square. This is equal to L2 square plus M2 square plus N2 square plus summation L3 square, that is L3 square plus M3 square plus N3 square. Now we will also get terms of 2 times summation L1 L2 plus 2 times summation L2 L3 plus 2 times summation L3 L1, all inside this root over summation L1 L2 means L1 L2 plus M1 M2 plus N1 N2, and similarly for these two terms. Now we can easily see that summation L1 square plus summation L2 square plus summation L3 square is equal to the sum of these three equations, that is equal to 3. Therefore on writing this over here we get this is equal to root over 3 plus this is L1 L2 plus M1 M2 plus N1 N2, that is equal to 0. Similarly these two terms are 0 plus 0, that is equal to root 3. Therefore we get the value of the denominator as root 3. Therefore let us write this down over here. Therefore we get the direction ratios the direction ratios are L1 plus L2 plus L3 upon root 3, M1 plus M2 plus M3 upon root 3, and N1 plus, let me write it clearly, we have L1 plus L2 plus L3 upon root 3, M1 plus M2 plus M3 upon root 3, and N1 plus N2 plus N3 upon root 3 as the direction cosines of this line. So we get the answer for our first part. Now we need to show that this line is equally inclined to the three given lines. Now let us find let us show that this line is equally inclined to the three given lines. So let us take this line first and this line. These are the direction cosines, and these are also the direction cosines of the two respective lines. Now, since they are the direction cosines, we can write cos theta, where theta is the angle between the lines, to be equal to L1 into L1 plus L2 plus L3 upon root 3 plus M1 into M1 plus M2 plus M3 upon root 3, and similarly the third term, that is N1 into N1 plus N2 plus N3 by root 3. This can again be seen from the vectors, from the formula for vectors. The above one is L1 I cap plus M1 J cap plus N1 K cap, and this is again when we apply I cap, J cap, K cap over here, we will see that this is this quantity I cap. Let me explain it like this. The direction ratios of this one is A1 I cap plus B1 J cap plus C1 K cap. Now since these two are direction cosines, the magnitude of these vectors are 1. Therefore we can easily write modulus A dot B is equal to modulus A modulus B cos theta. Modulus A modulus B both are equal to 1, that is cos theta is equal to A vector dot B vector. This is what we have written here, that cos theta is equal to A vector dot B vector. Therefore when we take dot product, we multiply the x coordinate by the x coordinate and write it here, the y component by the y component and write it here, and the z component by the z component to write it here. So let us solve for cos theta now. This equation can be seen as, this is equal to summation of L1 square, that is L1 square plus M1 square plus N1 square, that is represented by summation L1 square, plus summation L1 L2 plus summation L1 L3 upon root 3. Summation L1 L2 means L1 L2 plus M1 M2 plus N1 N2. Now we clearly see, as we had the equations previously, we know that L1 L2 plus M1 M2 plus N1 N2 is equal to 0, and similarly this term is also 0, and summation L1 square is equal to 1, that is L1 square plus M1 square plus N1 square is equal to 1. Therefore we get this as 1 upon root 3. Therefore cos theta is equal to 1 upon root 3, that is theta is equal to cos inverse 1 upon root 3. Now we have to check for the other two lines also, but we need not check because we can see it directly. Since there was no biasness between L1 L2, between L1 M1 N1 and L2 M2 N2 and L3 M3 N3. Similarly, we can say that for the combination of this line and this line also, the result will come out to be the same, because this term has no biasness between L1 M1 and N1 and L2 M2 N2 and L3 M3 N3. Therefore, similarly we can write that for these two lines we will have the same angle, and for these two lines we will have the same value for theta, and hence we prove that all the three lines are equally inclined to this line, and the angle of inclination is cos inverse 1 upon root 3.